Okay, so welcome back. So in this video, we're going to show how to, or I'm going to show how to find the area between two polar curves. Okay, so in this example here, we've got two curves. Now, I'm going to say this because you need to remember, you got to recognize what these curves are. Again, we study the form of the equations and how they give you the different shapes and how they're oriented. It's going to help you, okay? So understand that this is the equation of a circle that starts at the origin and goes up and around, and it has a radius of 6, okay? Now, this is a cardioid. This is the form of an equation that represents a cardioid. Sine plus tells you that it's going up and it's going in this direction, okay? Okay, so again, use these to help you orientate the graphs. And so you could sketch the graph of the cardioid and the circle relatively easy, okay? So now, the thing is once you get the cardioid and you find out, hey, what this distance is here, what this distance is here, the radius, then you can get an idea of what it looks like. Or just plot some points. Doesn't matter, but you could get the sketch of the graph, and then the sketch of the graph will help you figure out what is going on. Okay, but the bottom line is we want to find the area between the two curves. Okay, so as you trace this one, okay, we want to find the area, and in particular, we want to find the area between the two curves here. Okay, that's what I shaded in. So let's say that's what we want to do, is we want to find that area, the area of that region. Okay? Well, the first thing we need to do is we need to figure out the interval of theta, right? We need to find our alpha and beta. Okay? So we need to find theta in the closed interval alpha to beta, right? We need to figure out our limits of integration, right? That's our alpha and beta. So how do we do that? Well, we set the two equations equal to each other and solve, just like we normally do in algebra, right? Just algebra. So let's do that. So we take 6 sine theta, we set it equal to 2 plus 2 sine theta, and then we're going to what? Subtract 2 theta from both sides, and we get 4 sine theta is equal to 2. And then we just divide both sides by 4, and we get sine theta equals half. And so now, this is where trigonometry comes in, right? So again, we have a right triangle, and sine is opposite over hypotenuse. And so what triangle gives us this sort of setup? Well, there's only one. 30, 60, 90. And so that means, what angle are we dealing with? Well, it's going to be a 30-degree angle here, right? So theta is a 30-degree angle. So what are the different 30-degree angles? Well, in the first quadrant, there's only one. Pi over 6. In the quadrant 2, there's only one. 5 pi over 6. And so there's our alpha and beta. Okay, so awesome. Now we know what the limits of integration are. Okay, so alpha is equal to pi over 6, and so that's why I drew these triangles here, right? So we know it's a 30-degree angle, so here's a 30-degree angle here, and then there's a 30-degree angle here in the second quadrant, but again, that corresponds to a theta, again, of 5 pi over 6. Okay, so, let's continue on. So now let's set up our integral for area. Okay, so we want the area of the region between the two curves from pi over 6 to 5 pi over 6 But we need to know how to subtract these. Well, it's going to be the area of the circle, the outside curve, minus the inside curve. Okay? So it's going to be the circle minus the cardioid. So it's going to be the area of the circle minus the area of the cardioid. Okay? Okay, so now we could set this up as separate integrals. So this is going to be the integral, 1/2 the integral from pi over 6 to 5 pi over 6 of what? Of f of theta squared d theta, but this function of theta is the circle, which is this one. So, in other words, we're going to write this as 6 sine theta quantity squared d theta. Now minus, so that's the setup for the area of the circle. Minus, now we're going to start over and we're going to set up the area for the cardioid. So again, we're going to set up the formula, 1/2 the integral from pi over 6 to 5 pi over 6 of the function squared, f of theta quantity squared d theta. But this function of theta that represents the cardioid is this one. So again, we're just going to replace that with 2 plus 2 sine theta d theta. And so this is squared. Okay, now, I can also write this as one integral, which is what I'm going to do right now. Okay, so this is going to be 1/2 the integral from pi over 6 to 5 pi over 6 of this minus, so again, I'm just pulling the 1/2 out, pulling the integrals out, and so I'm going to write this as one integral minus 2 plus 2 sine theta quantity squared d theta. And so now I can treat this as one thing and simplify it. So let's do that. So now this is going to be 1/2 pi over 6 to 5 pi over 6. Now again, when we get to the point where we're going to FOIL this out, we've got to make sure that we distribute the subtraction. Don't forget to do that. Okay? Okay, so this is going to become 36 sine squared theta minus the quantity 4 plus 8 sine theta plus 4 sine squared theta d theta. Okay. So now I'm going to distribute the subtraction and drop the parentheses. So this is going to become minus 4 minus 8 sine theta minus 4 sine squared theta. Okay, so now let's go back up here. See where we're at. So now I'm going to start simplifying this. So I'm going to combine like terms and simplify. So this is going to equal 1/2 the integral of pi over 6, 5 pi over 6. So let's combine like terms, simplify things. So this is 36 sine squared theta minus 4 sine squared theta, which gives me 32 sine squared theta. And then I'm going to get a minus 8 sine theta. And minus 4 d theta. Okay, so all I did was combine like terms. Okay, so now, what do I do with this? Well, everything's fine except for this. So I'm going to use the property, I'm going to rewrite this using one of the identities, the identity that I used before. So this is going to be 1/2. Oh, by the way, I'm going to factor out a 4 too. Let's do that too. So if I factor out a 4, let's do that up here. If I factor out a 4, this is going to become 8. So let's put a 4 here. So this will be 4 over 2. This will become 8. This is going to become 2. And this is going to become 1. Okay, now, so this will become 2. Now I'm going to do, again, my integral stays the same, pi over 6 to 5 pi over 6. Now this is going to become, what, 8 times, this is going to be, well, let me put a bracket here. This is going to be 1/2 times the quantity 1 minus cosine 2 theta. Okay, and then of course, minus 2 sine theta minus 1 d theta. And so again, what do I get? I get, let's do this. So it'll be 2 pi over 6, 5 pi over 6. And so what happens here? This is going to become 4 minus, yeah, so this is going to become, this will become 4, so it's going to be 4 minus 4 cosine 2 theta minus 2 sine theta minus 1. Okay, so now I'm going to combine like terms again, the constant terms. Which is going to give me what? It's going to give me 2 times integral of pi over 6 to 5 pi over 6, and this is going to give me a negative 4 cosine 2 theta minus 2 sine theta plus 3 d theta. And now it's time to integrate. Okay, so let's integrate this thing. So we're going to get 2 times what? This is going to become what? So the antiderivative of cosine is sine. So this is going to become negative 4 divided by 2, because I got to divide by the integral, the derivative of the inside, which is 2. So I'm going to get negative 4 divided by 2, which is just 2. So I'm going to get 2 sine 2 theta. Okay? And again, if you don't believe me, just take the derivative of this, right? The derivative of sine is cosine times the derivative of the inside, which is 2. So we get negative 4 times cosine 2 theta. Okay. The next one. The antiderivative of sine is negative cosine. So the derivative of negative sine is going to be positive cosine. So this is going to be plus 2 cosine theta plus 3 theta. And this is going to be evaluated from pi over 6 to 5 pi over 6. All right, so we're almost there. Now, so this is going to become 2 times, I'm going to evaluate this at 5 pi over 6. So this is going to be negative 2 sine of 2 times 5 pi over 6, which is what? 5 pi over 3. Okay? Plus 2 times cosine of what? 5 pi over 6. Plus 3 times 5 pi over 6. So I'm going to subtract. Now I'm going to subtract evaluated at pi over 6. So I'm going to basically do everything at pi over 6. So this is going to be negative 2 sine of 2 theta, which in this case is going to be then pi over 3, plus 2 cosine of pi over 6, plus 3 times pi over 6. Okay, so now it's time to just simplify things. Okay, so now, okay, so this is going to give me, again, this is 5 pi over 3. So 5 pi over 3 gives me what? 1, 2, 3 pi over 3, and then I get 60 degrees. So pi over 3 is 60 degrees, so I'm going to do 5 60 degrees. So 1, 2, 3, 4, 5. So I've got a 60-degree angle in the 4th quadrant. Okay? So that's going to be sine is opposite. So opposite a 60-degree angle is pi over 3, which is going to be negative. So this is going to be negative 2 times the square root of 3, negative square root of 3 over the hypotenuse, which is 2. Okay, now, now cosine of 5 pi over 6, well that's 30 degree angle, okay? So the reference angle is 30 degrees. So the cosine of 30 degrees is, in this case, the same as this one. So this is going to be 2 times negative square root of 3 over 2. And of course, this is going to be plus 5 pi over 2. Okay. Okay, so that's that piece. Now, let's distribute the subtraction here. So this is going to end up being plus. This is going to end up being minus. And this is end up going to be minus. Okay, so now I'm going to add 2 times what? The sine of pi over 3. So the sine of pi over 3 is, again, a 60-degree angle. So that's going to be opposite. So this is going to be positive square root of 3 over 2. Minus 2 times the cosine of pi over 6, which is the cosine of 30 degrees, which is the same as sine of 60 degrees. So this is also going to be the square root of 3 over 2. And then minus, this is just going to be what? It's going to be pi over 2. Okay, so now, all right, now we can start combining like terms now. So let's go for it. Okay, good. So let's see. Well, this 2 is going to cancel with this 2. Negative is going to cancel with negative. So this is going to end up being 2 times what? The square root of 3. Plus, this is going to cancel with this one. So I'm going to get minus the square root of 3. Plus 5 pi over 2. Plus, this is going to give me square root of 3 over square root of 3. Okay? This is going to give me minus the square root of 3 minus pi over 2. Now things start to simplify. Well, this and this equals 0. This and this equals 0. Well, look at this. We get 5 pi over 2 minus pi over 2 gives us 4 pi over 2, or 2 pi. So this equals 2 times 2 pi, which gives us 4 pi, and that is the answer. So the area between the two curves is 4 pi units squared. And that's it. Have a great day.